of Maths in the Shed. We're on the basketball court here, and if you know anything about basketball, you can either score 1, 2 or 3 points. 2 of those numbers are prime numbers. Hi, good afternoon. We're going to work out how we can work out those prime numbers between 1 and 100 using a technique called the sieve of Eratosthenes. Eratosthenes was a Greek mathematician who was born about 274 BC. Now, 1 does not count as a prime number for a special reason. So we're going to cross that off. And what we're going to do, we're going to circle the prime numbers and cross off the non-prime numbers. Now, 2 is the only even number, so even prime number. So we'll circle that. Any other number that's a multiple of 2 cannot be a prime number, because a prime number can only be divided by itself and 1 and cannot be divided by 2, for example. So 4 can't be a prime number, 6, 8, etc. 10. So using this number grid, I can tell that all the multiples of 2 are not prime numbers. And I'll cross those off as quickly as possible. That's all the multiples of 2. 3 is also a prime number because it can only be divided by itself and 1. And I will now cross off all the multiples of 3 that I've not crossed off already. So 9, 15, 21, 27, 33, 39, 45, 51, 57, 63, 69, 75, 81, 87, 93 and 99. I can do the same for 5. Well, that's the easiest, all the multiples of 5, so that's everything in this column. And I've crossed off all the other multiples of 5 already because there are also multiples of 2. And you can do the same for 7. And we just go for the 7 times table. 14, 21's already crossed off. 35, 28, 35, 42, 49, 56, 63, 70, 77, 84, and then 91. I don't need to go any further on check for anything multiple of 11 because my highest number was 100 and the square root of 100 is 10. So basically, if I did 10 times 10, I get 100. If I did 10 times 11, for example, I get 110, which is bigger than 100. So I don't need to go any further. So basically, you look for the biggest, you look for the square root of the biggest number that you've got, okay? And go up to that number. So in this case, my largest number is 100, square root of 100 is 10. Anything I've got left are my prime numbers, which I'm now circling. And those are my prime numbers. Okay, now on this sieve of Eratosthenes, I've got 2 types of numbers. The prime numbers, which I've circled. The other numbers are called composite numbers. And 52 can be divided by 26, and 2 or it can be divided by 13 and 4. So that's an example of a composite number. So I've picked one of the composite numbers, 63, and that can be divided by 9 and 7. Both and 3, and I circle those, and 7's a prime number. So 63, for example, can be made up of a prime number of prime factors of 3 times 3 times 7, which can be abbreviated to 3 squared times 7. And all other numbers can be made up that are not prime, can be made up of prime factors. Okay, then we're going to go through 2 exam questions. We're going to go for 2 exam questions. The first one is foundation, and it says x plus y equals 100, where x is a square number and y is a prime number. So, if you don't know, the square numbers are, for example, 1 times 1 equals 1, 2 times 2 equals 4. So these are the square numbers, 1, 4, 3 times 3 is 9, and then if I just write down the rest of them, it was 16, 25, 36, 49, 64, 81, and 100. Okay, so that's the square numbers up to 100. And I'm told that x and y equals 100, where x is a square number and y is a prime number. Well, I know that if I do 81, which is a square number, plus 19, and that's on my sieve, if you looked earlier, 19, well, 81 plus 19 equals 100. So that's my answer for the foundation type question. With a bit of algebra, and we've got to write an expression for the area of this rectangle. Well, we know to work out the area of a rectangle, we have to do the length times the height. Okay, so the length is 3a, the height is 5b. So the expression for area is 3a times 5b. We don't normally write the times sign when we're writing algebra, so that simplifies to 15ab. That's part A. Part B. We're told the area is 315 centimetres squared, and that A and B are prime numbers. Well, I know then, I've got my expression, 15ab, so 15ab must equal the area, which is 315 centimetres squared. AB must be 315 divided by 15, because all these 3 things are multiplied together, the 15, the A and the B. So AB equals 315 divided by 15, which is 21. AB in algebra means A times B. So I've got to think of 2 numbers that are prime numbers that we multiply together to give me 21. Well, one of them would be 3, and the other 7, because 3 times 7 equals 21, and they're both prime numbers. So A equals 3 and B equals 7. So that's the typical prime number question you may get on a higher paper.